Students, let's try to solve a problem on eccentric loading. It is question number 2, assignment number 5. A C clamp is subjected to 40 kN vertical load, having rectangle cross section. The perpendicular distance between the load axis and the neutral axis of the cross section is 140 mm. Find the dimensions of the cross section of the clamp for the permissible stress value of 110 Newton per millimeter square. Take depth of the section as twice of its width. So let's draw the sections. So here C clamp is given, which is subjected to vertical load of 40 kN. Now the cross section is given is rectangle. So this is B and this is D. Now B is given 2 times of its depth. Now distance between load axis and the neutral axis is 140 mm. As the load acting vertically at section 1, the stresses, that is direct stress and bending stress, get added, and at section 2, the direct stress and bending stress are opposite to each other. So let's find the maximum stress at section 1. Maximum stress will occur at section 1, which is a summation of direct stress plus bending stress. Same way at section 2, direct stress minus bending stress, right? So from above equation, it is very clear that stresses at section 1 will be maximum. So we are going to consider the maximum stresses at section 1. So here sigma max is equal to P by A. Bending stress is equal to load into distance divided by section modulus Z. Now here we have given the maximum vertical load is 40 kN and the cross section is B into D. Same way for the bending stress, 40 kN load, its eccentric distance divided by section modulus Z. Here the self stress is given is 110. So let's simplify the equations. (40 kN). Now replace B by 2 times its depth. Same way here, 40,000 multiplied by 140 into 6. This 6 value will goes up. Now let's replace B by 2 times depth. Now here I am going to write D instead of H. So here it is 2D, or you can say D square. So total will be 2D cube. Now let's multiply both sides by 2D cube. So it's going to be 1110 into 2 into D cube. Here it will be 40,000 into D. Here it will be the multiplication of these 3 terms, which comes out to be 2400 into 140. Now let's simplify the equations. Now let's divide both the side by 220. So D cube, this comes out to be 182D, and this will be comes out to be 152727. Okay, now let's write in a proper format. D cube minus 182 minus 15727 is equal to 0. Okay, so this is our final equation. Now we want to find out the value of D for which this equation or left side of the equation becomes 0. There is a shortcut trick here. Here the maximum power is cube and the constant term is this one, right? So you have to take the cube root of this term. So that way we are able to reach to the nearest value of the D value. So here it comes out to be D is equal to 53. So how we have to find out this? So 152727 cube root of that value, right? So that gives nearest value of 53. So for 53, what is the left hand side. So let's write it. So left hand side of equation is minus 13,496. You can calculate using calculator. Now let's increase value of d to 56 and let's find what is left hand side. So put this value in this equation number 1, and find out the left hand side. Now it comes out to be 12697. So this is positive. So by looking at this value, it is very clear that our answer lies between average of these two values, that is average of 53 and 56. So let's take 54 value. So left hand side will be minus 5091. Now the value is between, you can say it is between these two, right? So the average of 56 and 55 is 54 is 55, right? So let's put the value d55 and find out left hand side value. It comes out to be 3638. So this is closest value possible. So by taking d55 value, left hand side equation is 3638. This is the smallest value possible. So our answer is 55 millimeter. Now we can little take higher value. D is equal to 56. Okay. So by taking 56 mm, we are going to increase the depth of the sections. That is 56, and this is going to be a 112, right? So here the B value is 2 times of that, which comes out to be 112 millimeter. So this is how you can solve the problem. So the final answer of the cross section is B is equal to 112 and D is equal to 56 millimeter.